Hi, Assalamualaikum and a very good morning. So now we're going to do tutorial discussion for chapter 8, focusing on the subtopic of 8.5 phenol. We're going to focus on three questions, which is tutorial question 11, tutorial question 12, and tutorial question 13 respectively. Without any further ado, let us start. So for tutorial question 11, the structural formula of X is shown below. We have to draw the structural formula of the product formed when X react with this following species here, which is A, B, C, D. So X is given as here, and then we're going to react X with sodium, which is sodium metal. So when this structure here, which is a phenol, as well as an aliphatic alcohol that align to the benzene, that is attached to the benzene, we can say that the sodium going to replace the hydrogen of the phenol. At the same time, the sodium going to replace the hydrogen of the alcohol. Okay, so phenol, and here is alcohol. So it become O minus and Na plus, and same goes to here, O minus and Na plus as the product. Okay, and now we can also react the same structure here, which is X, and then we're going to react that with the sodium hydroxide. So sodium hydroxide going to have a formula of aqueous NaOH, or you can write it as sodium hydroxide NaOH here. Okay, so the sodium hydroxide also acting as a base, but it needs a strong acid in order for it to react. So the phenol part is the more acidic part in comparison to the alcohol, where it is due to the stability of the phenoxide ion when it dissociates in water. Okay, so when you know that phenol is more acidic, the phenol can react with NaOH aqueous. However, the aliphatic, which is least acidic, cannot react with NaOH. So only this part here, which is H, going to be changed with Na plus, but for this side, it's not going to be any changes that is happening. Okay, so the changes going to happen on this side, but not on this side, because alcohol here is a very weak acid. Okay, now for C, we're going to use the same structure here, which is X, and then we're going to react that with the phosphorus pentachloride. So phosphorus pentachloride means that it is a phosphorus. Penta refers to 5. So Cl5. Okay, so for phosphorus pentachloride, it's going to replace the OH of the alcohol and change it with chlorine. However, the phenoxide, where OH which is attached directly to the benzene ring, will not be replaced. Okay, reaction of substitution tak akan berlaku dekat phenol. It only happens on the alcohol. Okay, this is because the phenol is already stable, so the removal of OH is not favorable. Okay, so they will not undergo SN1 or SN2 in the phenol. Here, they will undergo SN1 or SN2 according to the strength of the nucleophile. Okay, so you know that this section gonna be substituted with Cl. Okay, now for the last part, which is part D, we're gonna react the same structure, which is X here, and then we're gonna react that with the propanoic acid, reflux with the traces of the concentrated sulfuric acid. Okay, so the meaning traces here is a very little amount. So you know that the concentrated sulfuric acid will going to be act as a catalyst. Okay, this is super important to know. So you're going to react your structure X with a propanoic acid. So propanoic acid going to have 3 carbon, and then at carbon number 1, it's going to be attached with OH group. Double bond O and OH group. So it's going to be carboxyl group, and it's going to be propanoic acid. Okay, so 1, 2, and 3, which is the same thing. And then with the presence of catalyst, which is concentrated H2SO4, you know that it's gonna undergo the process of esterification. Okay, so for esterification, the carboxyl part gonna react with the alcohol part. The phenol will not take place in the reaction. So alcohol with carboxylic acid. So alcohol gonna lose the hydrogen and the carboxylic acid gonna lose the OH group here. Okay, and then they're gonna attach together. So they have 1, 2, 3 carbon, right? So it's gonna attach at the oxygen here, and it's gonna have 3 carbon attached to it. 1, 2, and 3. Okay, and at carbon number 1, it's gonna be double bond O. So here gonna produce an ester because O, C double bond O here refers to the ester group. Okay, so you can draw it here, and this part here will not take part because it is a phenol. So you don't change anything here. What you change is on this side. So you can draw it in terms of the the skeleton structure here, or you can do it in terms of the condensed structure here, which is 1, 1, 2, 3, where the 1, 2, 3 here come from the carboxylic acid, where it is bonded to the alcohol part. Okay. Moving on to the next question, which is tutorial question 12, we have to explain the following observation. So phenol is soluble in aqueous solution of sodium hydroxide, but the cyclohexanol is not. So the best observation that we can see from here is that we know that phenol is much more acidic, most acidic in comparison to alcohol, which is least acidic. So the most acidic phenol will react with the aqueous sodium hydroxide. Okay, so phenol gonna react with sodium hydroxide aqueous, and this gonna replace the hydrogen with Na plus. Okay, and this gonna produce a sodium phenoxide, and the byproduct here gonna be water because hydrogen that gonna be removed gonna react with OH in order to produce water. Okay, however, cyclohexanol, which is this structure here, is very least acidic, so it cannot react with sodium hydroxide. Okay, no observable changes. However, as mentioned in the previous slide, the alcohol, the cyclohexanol, can react with the sodium metal only. Okay, but it cannot react with the sodium hydroxide. It can react with the sodium metal. Okay, so this is the information that you need to know. But for phenol, it can react with both Na and it can react with NaOH. Alright, and this shows that phenol is more acidic than cyclohexanol and therefore it can react with both. So phenol can react with a base to yield sodium phenoxide, which is a soluble salt. Now for question B, the ethanol gonna react with the iodine in aqueous solution of sodium hydroxide to produce yellow precipitate, but 1-propanol does not. So yellow precipitate here refers to the formation of the CHI3, which is triiodomethane. So you know that this test is known as the iodoform test. Okay, so iodoform test is used in order to detect the presence of the methyl carbonyl group. So when the structure have OH, CH3, and H here, and this site doesn't matter. When the structure have CH3, OH, and H attached on the carbon, then it's gonna give a positive result. So for in this case, ethanol gonna give yellow precipitate because it has this structure here. So if we were to throw ethanol, so ethanol will have two carbon, right? So we're gonna have 1 and 2, and then at carbon number 1, it's gonna be attached with OH. Okay, so this carbon here gonna be attaching with hydrogen, and CH3. So as what you can see here, this carbon will have attached with CH3, will attach with OH, and will attach with hydrogen. And for this thing, it doesn't matter whether it is CH3 or CH2 or H here. Okay, so in this case, it has a methyl carbonyl group as shown here. So this is going to give a positive result. So let us draw an ethanol. Okay, so this shows a methyl carbonyl. So it can react with iodine in the presence of the aqueous sodium hydroxide in order to produce a carboxylate ion, which is C double bond O, O minus, and A plus, and H here. And for the carboxylate ion, you can see that the number of carbon gonna reduce by 1. Initially it got 2, but now it got 1 for the carboxylate. And the other carbon here gonna react with iodine, CHI3. Okay, so what I'm gonna get here is plus CHI3, which refers to the yellow precipitate. Now, if I were to draw the 1-propanol, so 1-propanol gonna have 1, 2, 3 carbon here, and here gonna be carbon number 1 because it attached with OH. So propanol, and then it gonna react with 1, 2. You can see that this carbon here will have H, H, and then we're gonna have the ethyl group. So it does not have methyl carbonyl group because it has a ethyl group here. So dia tiada lah. Okay, so the structure must have carbon, CH3, OH dengan H. Yang kat sini dia ada CH, CH2, CH3, which is gonna give a negative result. So when this 1-propanol react with iodine at aqueous and AOH solution, it's gonna give a no observable changes, or you can say that there's no formation of the yellow precipitate. Okay, and the reasoning is yellow precipitate is produced by ethanol because the ethanol has the methyl alcohol group or methyl carbonyl group. So all here refers to alcohol, okay, which is this structure here, whereas 1-propanol does not have methyl alcohol group. Okay. Now for tutorial question 13, we have compound Y, which has a formula of C7H8O. It is insoluble in water, tidak larut dalam air, tidak larut dalam HCl and aqueous NaHCO3, but dissolved in dilute aqueous in AOH. Okay, so when Y is treated with bromine water, it is converted rapidly into a compound with a molecular formula of C7H5OBr3. So, bila direact dengan bromine in the presence of water, the 3 bromine molecule will be attached to the original structure of Y here. So, the stuff that is, the keyword here is, it is dissolved in the dilute aqueous NaOH. So you know that alcohol will not react with NaOH, but phenol will react, and it gonna dissolve because it gonna have a reaction. So you know that the C7H8O gonna be a phenol. Okay, let's say my OH is here. Okay, So if I were to count the number of carbon, I'm gonna get 1, 2, 3, 4, 5, 6. Gonna be C6. H, I'm gonna get 1, 2, 3, 4, 5, and 1 here, 6. And oxygen, I'm gonna get O, because 1 oxygen here. Okay, and I know that what's left is my structure need to have C7H8O. So I'm lacking, I need to add CH2 in order to get to C7H8O here. Okay, so what I'm going to do is I'm going to attach a methyl group. So anywhere that I wanted. Okay, so let's say I put it on this one. I'm going to get it as CH3. Okay, so CH3, because originally it got one H, right? But now it combined together, it becomes CH3. So this gonna complete my molecular formula here. So you can count it again. So the carbon 1, 2, 3, 4, 5, 6, which is and 7 here. So you're gonna get C7, and then hydrogen gonna get 1, 2, 3, and 4 hydrogen. 1 here, 5, and then 3 hydrogen here, which is 8. And then oxygen gonna be O here. Okay, so I know that I'm gonna get this structure here, a phenol with a substituent of methyl. Okay, so you might be asking, sir, can I put my CH3 on carbon here, or can I put my CH3 on this carbon here? So for the matriculation level, it doesn't matter where you put it, but later when you go into the degree, they're gonna be a much more possible or suitable place in order to put the CH3. So it gonna favors auto and para. Okay, but for now you can put it wherever you want. Okay, so I can suggest a structural formula of Y, which is need to be phenol. So it gonna be a phenol, and the CH3 gonna be attached at carbon number 3. Okay, so I can say that it's gonna be 3-methyl phenol. Okay, and then I need to write all the equation involved, because the 3-methyl phenol here gonna react, which is labeled Y here, gonna react with bromine water. So 3-methyl phenol gonna react with bromine water. It's gonna react with NaOH first, because only phenol gonna react with NaOH, not alcohol. So this gonna causes hydrogen here to be replaced with the sodium plus. Okay, and this gonna be not affected. Okay, and at the same time, the 3-methyl phenol gonna react with the bromine water. So bromine water gonna be plus Br2 in the presence of water, and what gonna happen here is that three bromine atom gonna be inserted at this region, at this phenolic ring here. So Br gonna be inserted here, Br gonna be inserted here, and Br gonna be inserted here. Okay, and this is the same as the identification test of phenol, where you're gonna add Br2, and then you're gonna produce a tribromophenol. Okay, tribromophenol, which is a white precipitate. Okay, ini adalah identification test that you have learned in your lecture. Cuma bezanya, it's gonna have a CH3 here and CH3 here. Okay, and because of this reason, the methyl group gonna be attached at carbon number 3 and not at carbon number 2, because the bromine here is an going to be attached at carbon number 2 and carbon number 4 and carbon number 6. Okay, and that is why we're going to put our methyl at carbon number 3, or else it's going to compete with the bromine in order to take this carbon here. Okay, so we're going to draw the structure as shown here. Okay, now for the last part, which is the confirmatory test. So for confirmatory test, we need to confirm that whether it is really a phenol or not. So what we're going to do is we're going to react our 3-methyl phenol here, and then in order to confirm that it is really a phenol, we're going to use the reaction with FeCl3, and which initially it is a yellow oil. Okay, and when we react it together, what we're gonna get is the FeCl3 gonna combine at the pi electron, which is FeCl3 here. Okay, and as mentioned, the FeCl3 gonna bond at the pi electron and not at the carbon chain, because it's gonna form a complex. Okay, the reason for that is much more complicated, but at least for matriculation level, it is sufficient for you to know. Cukup untuk kamu tahu saja FeCl3 akan bond di tengah-tengah. Alright, so you're going to draw the structure again, make a pi bond, which is the localization of electron, and the FeCl3 going to be placed in the middle. So from yellow oil, it's going to be changed into a purple complex. Okay, alright. So I think that's all for today's video. See you again some other time. Bye.